Alright, so this is 5.3 logarithmic functions and graphs, and this is part 3. So we're looking at converting each of the following logarithmic these exponential equations into logarithmic equations. So the thing we're looking at is how do we go about doing that? How are they related? And the base here is going to be the same base as on the log. So our exponent or exponential function has a base of 2, so we have a log base 2. Our output after we've used we've solved for our exponential function is 16. Here we're saying what would be the exponent if we're solving using a base 2 of 16. All right, so that's pretty straightforward. Again, let me show you the next one. It's talking about when we have base 10, and it's going to give us a negative value because it's going to be less than 1. All right, so in this case we have the negative 3 is our end result. We've got our log base 10, and then in order to do that you're going to have to move 1, 2, 3 over in order to have this be in our thousandths place. All right, and then our e to the t equals 70. That's going to give us log base e. 70 equals t. All right, so hopefully it's becoming clear where all of these numbers wind up and how they're related to each other. All right, let's go on to our next page. Now we're going to go from logarithmic back to exponential. So in our first case, we have our log base 2, 32 equals 5, and we have the base 2 on our exponent, and we raise it to the 5th power, and we get 32 as a result. Very similar process for our next one. We're going to have a is our base, 8 is our exponent, and q is our ending answer. And in this case we have t is our base, x is the exponent, and m is our ending result on our exponential function. Alright, so this has to do with setting up how to solve for we would be solving for logs. And one thing I want to point out is we can kind of make an estimate about how these things are going to behave. And I'm going to pause the video here in just a second, and then I'm going to put up a screen and we'll work through how this works. But I want to make sure that everybody's understanding we're looking for something in between the 100,000 and 1 million category. And we're going to talk about what that is and how come we can wind up with this value. All right. Okay, so in our first case, we're being asked to find the log of 645,778. So we're looking for something that's going to fall between 100,000 and 1 million. All right, and this is definitely going to fall between that. That's going to be our 645,778. So our 10, using our base 10, we're going to have 1, 2, 3, 4, 5. So our exponent is 10 to the 5th here, and on this one it's going to be 10 to the 6th. All right, so we know that our answer for the log on this particular problem has to be larger than 5 but less than 6. This is a little bit past halfway, so we're expecting our number to be closer to the 6 than we would the 5. Okay. And as you can see, it is in fact going to be 5.8, which is between 5 and 6. Similarly, we're going to do it with the negative values. We're going to have a -4 and a -5 is where we would look. We know that this is going to be a negative. It's going to fall somewhere in the middle. So -4.6 seems like a reasonable number for this. Here on log base log base 10, -3 gives us a non-real answer. It doesn't exist on our real number line. I do want to point out that that does not mean we do not have a solution, only that it is not real. We do actually have a complex solution to be able to solve for this. All right, so we've talked about log base E. Now we're going to talk about kind of a shortcut for that. We have ln x means the log base E of x. All right, and same rules apply. So if I have ln 1, I know my exponent had to be 0. If I have ln of E, remember this is the same as our log base E, right? So that means it's got to be a 1. All right. In this case, we have the same set of numbers, and in the last case, we had like 5.8 something. In this case, we have 13, and the reason we have 13 is because our, let me get the pen here, our result is based on the base, okay? So log base 10, we said it was between 5 and 6, so we'll call it 5.8. Remember, it's something like that. And in this case, we're having log base E. And because log base E is going to equal 2.17 or 2.71, 2.71812, something like that. Anyway, it's not very, it's less than 3. It's close to 3, but it's less than 3. So I'm going to have at least that many times. I'm going to have more times that I'm going to have to multiply something or raise it to an exponent in order to get that same value. So here I have a 5.8. This is going to be just about 3 times that, right? So this is, you know, it's a little less than that, but it's the same general idea. Is we're using this base on the E, and we're going to wind up with something over 13 because we're multiplying this 2.7. All right. So in these cases, it's pretty straightforward. Again, we're going to just use a different base. That's the difference. The thing we need to keep in mind is how those things operate. Okay? We need to keep in mind that one is log base 10 and the other, the ln, is log base E. All right. So again, our ln of -5, it's not going to have a real answer, right? Because we don't have any negative numbers that we can use in that case. We have ln of E is going to give us a 1, and ln of 1 is a 0. Those are our givens. Those are like our automatic, always kind of happens thing. And we're going to talk about change of base formula. And we're going to be able to go from one base to another base. And at this point, I'm going to stop the video and we'll pick up with part 4 in a moment.